Welcome gentlemen once again. We are discussing about ship types. We have seen the container ship developments. You will realize that container ships are basically unitized cargo ship. There are other unitized cargos, and the units that are moved by sea other than containers are the so-called barge carriers. Like container ship, container is a unitized cargo suitable for intermodal operation between road, rail, river and sea. A barge carrier carries a unit called a barge, which is suitable for moving intermodal between the sea and river. Normally there are many ports in the world at the river mouth, and it would be of course a natural offshoot of such geographical location of a port that if the cargo could be taken along the river to hinterland. In India such situations are plenty. Calcutta, Haldia is next door to us at Kharagpur is a prime example where if we had a vibrant river navigation system in the Ganges and Brahmaputra, then we could move cargo from sea to right up to Assam on one side, up to Dibrugarh on one side, or up to Allahabad on the Ganges. And to do this most efficiently, see what are the methods of transporting cargo from ship to a river barge. One would be that you unload the cargo and put it in a barge, load the barge and go. But loading and unloading, as you know, is a very expensive process and is dependent on stevedores, and stevedores are not easy to please, so you have to pay a very high amount of money. Perhaps a more efficient, more economically efficient system would be if I can carry the barge on the ship itself. The barges are loaded like a container, close the hatch covers, load the barges on the ship. The ship would be designed to carry barges and take it to the port, unload the barges go away on their own power, or as we discussed previously, it could be pushed or pulled. Yes, we have three standard types of ships in barge carriers: lash, packet and CB. Have you heard of all these ships? This is lighter aboard ship. That is what is called a lash ship. The barges are called lash barges. And a standard barge size of a lash barge will be 18.745 meters into 9.5 meter beam and a depth of 3.96 meters. This is the standard for lash barge. Now backcut barge dimensions I do not have with me right now, but I will give you later. Backcut is barge carrying catamarans, whereas lash and CBs are American designs and concepts. Backcut is a European concept where you have 3 or 4 different standard barges which are designed in such a manner that they can be locked onto each other like containers, or one barge can come on top of the other and be locked together, and they have half lash barges and full beam barges, and depth wise also half depth or full depth lash barges are there. There are a number of combinations, 3 or 4 standards are there. In fact, I will give you the diagrams along with the dimensions in some other class. These are carried in catamaran vessels where the barges are hooked up to the hull from underneath, and some barges are also loaded on top. So when the backcut ship comes to the port, All it has to do is sink itself and unhook the barges, and the barges will float and go away. CB is a ship where it carries also a CB barge, which is much larger in dimension than this lash barge. These are this is also a much, if you look at ship design and construction, you will find the dimension of CB barges. These barges, these vessels are actually have one peculiarity, that is they have very heavy lifting arrangement on board the ship, because these barges have to be lifted and put on themselves. So the heavy lift arrangement is there in almost all these barges, either through a crane or through an elevator. Elevator which can lift the barges and also move to put it in the condition. So as you can see, these are capacity oriented vessels. Large amount of volume is there, but you cannot fill it up with cargo, because the barges also, like containers, they will be half filled, and barges don't take up all the space. So you have a lot of empty space left in the ship. So unless the freight supports movement of such cargo, these vessels are uneconomical. For example, I would think that these backpack type of vessels are a solution to the Indian environment, where if we had a vibrant river transport system, maybe many of the ports could use such barges for hinterland transport, starting from Calcutta, come to Paradip, you have the Brahmani Mahanadi river system. Vizag, no river of course is there. Madras, you leave it. Go to the other side, Goa, Bombay, Surat, lot of rivers are there where it can be used. But unless they are done properly and managed properly, this is an expensive proposition. Okay, so next let's look at tankers. When I say tankers, it's a carriage of liquid cargo in bulk. It could be crude oil, could be product tanker, or even it could be any other liquid carrying ship. This is one vessel which has really seen tremendous amount of changes in Second World War. As we discussed earlier, after Second World War, the oil was the fossil based oil, that is fuel oil, was very cheap, and therefore it necessitated carriage of this cargo by sea, where the freight was very low. Slowly, as technology advanced, the vessel size increased, people thought of economy of scale, and large amount of oil could be moved cheaply at sea. What was the feature of such a tanker? Let's see what is the feature of such a tanker. You had a hold. Let me show you let me draw a cross section of it. Since it was a liquid carrying ship, cargo was handled by pumps and pipelines. There was no need of a hatch cover, right? Was there a need of a double bottom? Perhaps there was no need of a double bottom, except for carriage of oil, fuel oil, for the propulsion plant to separate it. Okay, there is strictly no need of oil this thing, because of another reason, that if there is a damage somewhere on the tanker bottom, the water that would come in would just replace oil of the same, nearly same density. So it is a very safe ship. There is no need to give a double bottom, and see the structure. It's very good structurally. There is no opening anywhere along the cross section. So entire deck was contributing to strength and no stress concentration because there are no cutouts in the deck. Further, just imagine, from whatever knowledge you have on strength, you can imagine this. The tanker will be loaded. Imagine the load curve, the weight curve. You know about the weight curve. You will have a certain amount of weight along the length of the ship because of oil loading. What will be the buoyancy? Buoyancy would follow the geometry of the shape again. So the buoyancy and weight curve would be nearly same. So therefore you will have hardly any shear force and bending moment. So just imagine, stress levels were low, vessel is safe, no complications with regard to cargo handling. And it's just ideal to carry cargo, isn't it? Isn't it? As a mariner you will say, this is really good. And this is what people said, that carriage of oil cargo at sea was the easiest thing to do. And as a result, you developed what is called economy of scale, led to bigger and bigger tankers. So what you had? The so-called VLCC and ultra large crude carriers, ULCCs, going up to 500,000 tons or even more, at least thought was there. So this was the scenario in the 60s and very early 70s. Then came the oil crisis, 71 war, and oil prices went up. So you see, when oil prices went up, suddenly there was no demand for movement of cargo at sea, oil as a cargo at sea. Country like India, if oil prices go up 10 times, obviously we cannot import the same amount of oil we imported. This happened all over the world. And oil tanker size suddenly reduced. I am not going to deal with the changes that took place in the shipbuilding side, looking at the design side alone, the development of tankers as a crude oil carrier. We see that suddenly there is a move towards building smaller and smaller vessels, because economy of scale is fine as long as you have full load of cargo. If you do not have full load of cargo, then you must build smaller ships so that at least your ship is full when it is moving. And as we have discussed earlier, tankers move only half their lifetime with cargo, other half they are moving in ballast. So the tanker size reduced, came down to 50,000-60,000. Now I think it is stabilizing around 100,000, 1 lakh or so thereabout. Slightly bigger than Panamax tankers are of course there, 60,000 to 70,000 tons, and people have built slightly bigger tankers, about 100,000-120,000 tons, not more than that. This occurred, then along with it the other thing, pollution, the tanker disasters took place, which became serious because of the world awakening to environmental issues, marine pollution. So you had a situation that if you moved a tanker, you are subject to pollution rules and regulations for carriage of cargo in bulk, tanker cargo. Also safety issues which were perhaps there but became more acute, such as fire fire hazards in tankers much more than. So, what did the shipbuilding scenario look like? We have an inroad of regulatory regime into ship development. And the regulatory regime said that you must do this to avoid pollution and safety hazards. And what are these? We will not go into details of it, but it suffices to say that we had to control pollution, we had basically two approaches. One is, what do we do for involuntary discharge of oil to sea? Involuntary discharge means when the ship's crew doesn't want a pollution to occur, but it has occurred, and this is typically the accident scenario, when you have an accident and the oil spills out into the sea. Number of such accidents. So the thought process that has gone on since 70s till now is, first we came to the scenario of protective location. Sorry? No, not zones. In the ship, we said we will provide the cargo space with protective location, not slop tanks. We said there would be empty spaces between the cargo space and the sea, but not completely around the cargo space. Okay. Today we are talking of double hull, but between double hull and no double hull, there is an intermediate area. That was in 1973 MARPOL regulations and 78 TSPP regulations, which talked about protective location of cargo tanks. That means certain percentage of the volume would have to be provided as buffer space between the sea and the tanker, and this was typically some side tanks and some double bottom tanks to be designated as ballast tanks. Not all. That was one stage of tanker development. Then the next stage came. Even this was not satisfactory, as we did the probabilistic damage assessment. It became clearer that a damage could happen anywhere in the ship's length and ship's bottom. So therefore, this protective location was not a safeguard enough to stop involuntary discharge of oil into the sea. So we had this double hull concept, where you have the complete side tanks and bottom tanks devoid of oil, and this cargo space, this inner space is a cargo space which is protected by an empty space all around or water ballast space all around. So in the event of a damage, the oil remains protected. This is the concept of a double hull tanker, which has grown from the so-called protective location regime. What is the effect of this double hull tanker? As a ship operator, you would of course like this as an operator, as a actual operator of the ship. You would prefer this design than this, because the cargo space is rectangular, easy to clean, easy to maintain, and you have ballast spaces separate, so no mixing, it's easier. But as a operator doing business in ships, you do not like to lose this space, which could have been your cargo earning space. So it becomes difficult business wise to have a double hull tanker. That is why it took such a long time for the world, 73 till today, for 30 years, for the double hull tanker to become a reality. You know that tankers are given type A freeboard, isn't it? Type A freeboard means minimum freeboard. This double hull tanker can never achieve a dead weight which will sink it to the maximum draft coming out of the type A freeboard. Do you understand? That means if this was the freeboard draft, if this is draft as per freeboard, Plimsoll-Lyle draft, you can sink this vessel to this draft only when you have enough cargo weight to sink the ship. Now, oil has a particular density and it can only go in covered holds, closed holds. Once you take away this space is not enough to give the ship the type A freeboard. So, nowadays for the double hull tankers it is very difficult to achieve the maximum designated freeboard, which means in other words loss of revenue, right. So, this is what has happened to tanker business. And of course, when we talk of voluntary oil discharge, that is discharged through engine room, through bilges, through tank washings and other things, you are aware that lot of extra equipment have been provided in ships for doing this. That is, you have the oil water separators, you have slop tanks which again take away freight running space, you have a what do you call that, segregated ballast tanks. Of course, you have segregated ballast tanks, segregated pipelines, segregated pumps, you have slop tanks, you have the small pipelines for cleaning. No, crude oil washing lines, of course, crude oil washing systems you have. You have this, sorry, no, you have these small pipelines for removing the, what is it called? Steam. No. You have these positive displacement pumps and small pipelines for stripping system, right? Stripping system, you have the crude oil washing system, you have the inert gas system without which you can't do crude oil washing, and you have the oily bilge water separator, you have the oil content meter to measure the oil content, without which you cannot discharge. You simply don't have an avenue to discharge, you don't have a line, and you have to log any discharge you make to the sea. So, you see what has happened is, from being a very cheap and structurally sound ship, it's slowly grown into a very complicated, expensive ship which cannot carry cargo as per its freeboard. And the stability has become a problem now, because you got so many empty spaces around the ship. Just imagine the case of a damage. The damage stability, which was never there in case of a tanker. We never thought of any damage stability calculations. Today you have to do the calculations to see that the deck doesn't immerse, the vessel will heel, the vessel will trim, and you have to make sure that the stability is adequate in all conditions of damage. So, this is the tanker scenario as of now, and let us see how it goes in future, because tanker cargo is, as the oil becomes expensive, the freight also becomes more, and to support that you have to have a more sophisticated vessel. You see very interestingly how the trade scenario matches with technical and environmental developments. Everything sort of matches, isn't it? So, this is how it is. Now, let us look at bulk carriers. We have here a bulk carrier. This is how a bulk carrier would look, right? You can tell me why the top sloping tanks are required? Yeah. Yeah. So, you have about 30 degrees inclination, so that any light grain which is likely to shift is restricted from shifting. your grain shifting will be limited to within the hatch covers. You have to calculate that and show to the authorities that your total grain shifting even inside the hatches is within a certain limit. But in bulk carriers, this is a problem. Grain shifting is a real problem. What is this for? What is the slope at the bottom for?
To prevent the bilge plate, protection of the bilge plate.
No.
For easier correcting.
Yeah, is easier.
Roll down of the grain.
Yeah, right. Roll down of the grain. Okay, bulk carriers were increasing in size as tankers, till about not to that big size, but fairly big, 2.5 lakh ton tankers, bulk carriers were thought of and perhaps built. But today, the scenario is same as tankers. Nobody wants to take risk in building a very large bulk carrier. So Panamax is the maximum size, going up to 100,000 tonners again, like tankers. Tankers and bulk carriers are more or less in the same size. You can tell me what do you do with this space?
Wing tanks.
Yeah, we can use them for ballast. You can also, if you are carrying a very light cargo, you could also use it for carrying cargo by providing manholes on top. We can use. Okay. Bulk carriers generally don't have a ship girder strength problem. The hatch cover, if it is limited to about half the beam or a little less than half the beam, then should not normally have a ship girder strength problem from the hatch side. But do they have any other problem? Am I making a correct statement when I say that the bulk carriers will not have a ship girder strength problem? Such as?
Recently have had a lot of problems because of corrosion.
I am talking about ship girder strength. Okay, let's see. This is the bulk carrier. Let's say this is a bulk carrier. The engine room aft bulkhead, engine room forward bulkhead, this is the peak bulkhead. Remaining is cargo hold.
Load curve is very difficult.
Why?
Suppose you are not loading in all the hatches.
Yes, that's right. Now suppose we have got a number of holes here. Sorry?
Artificially cargo will load in all the hatches. Full we cannot load. So no. That is
Why not?
stress calculation.
Why not? It's like this. If I have got a light cargo, I can load all my cargos, all my holes.
For ore,
Suppose I am carrying heavy cargo. Ore is a little extreme. We look at ore separately. Let's say I am carrying fertilizers, where the density of cargo is roughly 1 ton per meter cube. I don't require all this volume. I have two options. I can load all the holes half till this, right, and go. Fertilizer is quite dense, it will not shift. The problem with this is I have to operate on 1, 2, 3, 4, 5, 6 holes at loading point and also at unloading point. That no operator will like to do. I have another option. I can load this fully, leave this empty, this I can make empty, and I can load this like that, empty, and load this empty, etc. This creates problem. Shear stress, of course, and so also bending moment, which may shift, maximum bending moment may shift from midship to the sides. You understand that? So you have a hull girder problem in bulk carriers, and you have to be careful about it. So your class gives a separate notation that specific hole loading condition is satisfied, and the holes have to be marked, which holes can be loaded and which can be left empty. Apart from this, as Mr. Mukherjee has already told us, there is a problem of corrosion in bulk carriers. But why specifically in bulk carriers? Why not other ships? Why in bulk carriers?
It's mainly because the cargo holds, after removing the cargo, the remnant cargo remains there, and water also tends to remain in those areas. And corrosion of the strengthening girders that take place weaken the girders in time. And the keel plate, the bottom of the ship, is the region where the higher stresses are involved. So damages arise from weakened girders, weakened frame, and the frames are such that access to those frames are also very difficult for investigation or checking, so they remain out of sight.
Yes, perhaps to some extent what you are saying is true. Two or three other things which apply to all ships, but bulk carriers perhaps more severely because of the same thing, the corroded plates. When plates corrode, they also undergo fatigue. Normally these cracks and things, bulk carrier failures that we have talked of, are generally for ships, for older ships. We don't hear of new bulk carrier breaking up and going down into the sea. So we have a problem of corrosion, no doubt, but corrosion is always looked at by the class, by the surveyors. Sometimes, of course, overlooking is there, no doubt, depending on access and sincerity. Let's put it, let's not be very moralistic about it. There is always a person's sincerity involved in this. But apart from that, old ships have a fatigue problem. A corroded plate, which is also fatigued, is perhaps more prone to cracking and failure than a new plate, a new replaced plate at the same place, because it is not fatigued. Okay, suppose for example a plate is lying on the floor, corroded. By mistake you have taken it and replaced on a ship. It is not fatigued but is corroded. Probability of its getting damaged, is causing a major failure, will be less than if that existing plate was there. Yeah. Now we talked about ore carriers. Ores, suppose I require a ship to carry ore only as a bulk cargo. How will I design it? Now let's see, a ore cargo will basically bring down the CG. That means my GM will be much higher. Do I require a really high GM? Answer is no, because high GM will cause faster rolling. I don't want faster rolling, the accelerations will be high. So I don't want. I want to maintain my GM within reasonable limit so that my rolling period is manageable. That's number one item. Number two is that do I still go for alternate hull loading if I have dedicated my ship to ore carriers? Then I should not really go for alternate hull loading. I would like to load ore on all the holes. Let's see if we can reduce handling problem. A typical ore carrier would look like this. Compare this with the bulk carrier we saw. See the bulk carrier, conventional bulk carrier we had, and this is the ore carrier. Compare them. The double bottom height is increased. We have had a very high double bottom. Also the side, we have a side tank which moves the cargo to the center. So the cargo is loaded here, automatically raising the CG. And I have got, answering Mr. Kumar's comment that cargo loading, unloading will be difficult. If you have smaller space, perhaps the difficulty is much reduced because you are handling the same volume. What is the alternative we have? Use the same bulk carrier, conventional bulk carrier with alternate hold loading or specific hold loading. Compared to fertilizer, the problem magnifies in ore carrier because ore is much denser. So wherever you are having cargo, you have a very large weight curve coming up, very high weight curve coming up there, much higher than uh, fertilizer. What is the storage factor of ore? It would be about 20 CFT per ton, whereas fertilizer will be about 30 to 35 CFT per ton and grain will be much higher, 50 to 55 CFT. 50 to anywhere up to 65 CFT per ton depending on the type of grain. Isn't it? So for this purpose, ore carriers are designed like this, leaving out a lot of empty space all along the length of the ship and raising the cargo to a height. You see, by shifting the cargo from the side also we are increasing the height of the ore that is loaded.
Because that will remove some height for the empty space.
That's right. Then as I mentioned, I would leave out cryogenic ships. Apart from saying just 2 or 3 sentences that these ships were started with about 5,000 cubic meters capacity, LPG and LNG carriers, but today we have 125,000 cubic meters cube of space of carrying capacity, going up to as high as 300,000 cubic meters, latest LNG carriers. Now these ships are basically 2 types. You have the circular spherical tank types, or you have the membrane type rectangular fitting into the ship size. A number of problems in cryogenic ships, apart from carrying cargo in either pressurized tanks or in cryogenic temperatures, and the technology for maintaining that pressure and temperature. You have a number of other problems, primarily on the material side. Correct me if I am wrong. Because you carry cryogenic substance in the tank, you have a problem of expansion of the tank itself and the ship hull, which is supposed to be at normal temperature, and it is sitting the support system. So you have the secondary barrier. But any leakage anywhere in this is likely to cause a fracture because of the low temperature of the cargo, brittle fracture. So it's dangerous. The same applies to pipes, pumps, supports for pipes and other things. So in a way, LNG, LPG carriers, the design wise at least, they have tested the ingenuity of designers. I think today there is a large demand for LNG and LPG carriers because of offshore oil, offshore gas production, which has increased. So let us see how these go, how these types of ships shape up in the years to come. Then we can think of, we can talk of integrated tug barge systems. Have you seen any?
Only the main part is there, other things are extra to tug is trying.
Integrated tug barge system at high seas. We are not talking of rivers. That is, you have got a big ship but without an engine, and you have the engine in a separate unit. Yeah. Have you seen one? Where?
Yes, it is posted once only in Hong Kong in Ocean water, but we are basically around that. Since it's an identical shape,
The fact you have that gap inside which it fits.
Yeah, right.
They are push tubs. They generally push tubs. They are along from Calcutta to Guwahati. They keep going.
No, that is different. See, what you are talking about is flotillas. Okay, it would be a tugboat system. Would be one in which the tug houses the engine. It gets into a recess in the upside of the barge, fits snugly, and then pushes the barge. It becomes one ship, and then it goes. Okay. Now in reverse, what we have flotillas. We have these barges. You can have a number of barges like this, or number of barges like this, and you have a tug coming up like this. This is a typically flotilla in a river. This is okay. This is also a tugboat system, but then this is a river tugboat system, which is not subject to the type of loading that a sea tugboat system would face. So what we have here, we can even tie up the tug and barge by ropes. We don't have to have more metallic connections. So by tying up with ropes, what we do, whereas when in contact the tug is trying to push it, it still has the freedom from the barge for moving up and down, the heaving and trimming motions, rolling motion. Most of the motions except surge are independent to each other. Okay, in this system, and as such in a river these loads are very less. So this is not a problem in rivers, but in sea this cannot be. In sea, a tugboat system would look something like this. This is a tug, and the barge would come barge is ship shaped in the forward end, and the tug comes and snugly inside. If you look at the bottom, it would be okay. This is the tug. These are there will be some connections here. The tug actually sits here, and then this is connected, as well as there are some connections here. So this becomes a single unit. Sometimes you may have a sort of a beam, a foldable beam, which comes from the barge, put on the tug and locked up. Okay. So this system, what is the advantage of this system?
The barge can be left in port and the tug can go carry other barges.
Yeah, it's maximum utilization of the tug. Also, it means that if one engine is out of order, you can have another tug, and it can push your trading is unhindered due to maintenance, repair, port problems, etc. And still go around and produce. Okay, this is sorry.
Less manual.
Less manning. That's very important. Yes. Okay, now let's talk something about passenger vessels. We haven't talked about passenger vessels, which is, do you think it's important?
Yes.
Yes? Okay, good. Passenger vessels, in the good old days when there were no planes, people moved by ships. And then came the planes, the aeroplanes, and the passenger movement reduced, virtually coming to a standstill in the 70s and 80s. Today we have an increased passenger demand. What sort of ships are in demand? Let's see.
How to ferry
Yeah.
maintain the strength?
If we talk of a ferry lasting 3 to 4 hours of journey, what will be our concept of such a ship? Just 3 to 4 hours. That is, say, crossing English Channel from Dover to Calais. 4 hours, maybe maximum 6 hours, not more than that. What sort of accommodation would you require? Because if the journey is small, less than a day, doesn't require sleeping accommodation, then you can do away with sleeping accommodation and you can put chairs, deck chairs at different deck levels, people can relax and go. Then what happens? You get large number of passengers. In India, you have passengers at various levels, and these passengers, the facilities you provide the passengers is only food counters and some toilets. No sleeping accommodation is required. You require a large amount of deck space, open deck space for people to enjoy themselves. In a scenario of such transportation in an advanced society, European or American society, people would like to take their cars along with them. So most of these ferries in Europe and United States are the Ro-Ro type. That is, you have got a lower deck in which you can drive your car, and at the other end you take it out and go. Upper decks are used for passenger seating. Now when you have this lower deck for Ro-Ros, apart from the deck space you provide, you have to make arrangement for the vessel to come in. So you have these ramps which act as closing devices for the, mainly at the stern. The stern itself acts, the stern closing, the transom acts as a ramp. What type of ramp is this? First requirement is, of course, it must hold the vessel watertight. And wherever you have a Ro-Ro type of deck, your transverse partitioning of the ship is not there. Do you understand that? Therefore, the Ro-Ro closing door becomes very important. Yeah, what is the name of the ship, name of the ferry that sunk off the Belgian coast? Freedom of Enterprise. So if you make a mistake in the closing of the ramp, either design of the ramp or operation of the ramp, the entire vessel is in trouble. Right? And of course, these vessels must be able to move around themselves, so they must have very good maneuverability, good speed, etc., etc. When you slowly move from these ferries to luxury passenger liners, you have a different kettle of fish altogether. You got to have people having sleeping accommodation, and depending on the status level, you got to have lounges, sitting spaces, reading rooms, all sorts of facilities on board, and the ship starts becoming more and more complicated. How do you design? How do you provide the space? If you look at today's luxury liners, you will find right from aft end till forward end, that is the accommodation. Unlike previous years, previous luxury liners, when the ship was shaped like this, that is as you increase the increase in height, it used to reduce. Today the accommodation is right from aft end to forward end and going up more or less vertically to as high as possible. The possibility is only with regard to stability. You are increasing the height, therefore the CG is going up, and so, and moreover large projected area for wind, and passenger ships, passengers don't like to roll very much. So from all these considerations, you are limited design wise how much you can go, but within that you have to provide all facilities. Apart from this, the requirements of a passenger ship are the stability should be such that it does not sink normally. Of course, that is there, damage stability, multi-hold criterion, etc. You are aware of all these things. You may have to have roll stabilization devices, passive or active. You have to have very good maneuvering characteristics. Therefore, you may have a bow thrust unit, you may have a stern thrusters as well, and you must have good speed. Therefore, high power. Extend it a little further from the conventional displacement mode luxury liner. What do you have? How do you move passengers still faster? You come to the hydrofoil and hovercraft scenario. We have touched upon this in our initial class. So if you want to carry large amount of passengers at a fast speed, then you must go for lifting surfaces or devices which are not only supported by this buoyancy, but other modes of support, and you must move passengers faster. Right? In this, sleeping accommodation is very difficult. This will normally be for smaller journeys, otherwise the economy does not break even, where you can move passengers over some distance, for large distance faster. Typical example was we had in Calcutta Silverjet, which was moving between Calcutta and Diamond Harbour. Now, of course, it is Haldia. Yeah. And in Bombay Harbour, we had hovercraft operation for a few years. Now, I think it's not there anymore. We had a ferry operation between Bombay and Goa. I don't know whether it's there still. But such vessels are likely to come in the future. This is going to be the future of passenger movement. Okay, we stop here. Thank you.